What is an iterator? This is a generator expression. Generator expressions give us back a generator object. We can pass a generator object to the built-in next function to get just its next item. What do you think would happen if we passed a list to the built-in next function? So if we pass a list to the built-in next function, we'll get a type error that says list object is not an iterator. What is an iterator? We know what an iterable is. An iterable is anything that you're able to iterate over. An iterator is the object that actually performs the iteration over an iterable. So from Python's perspective, an iterable is any object that you can pass to the built-in iter function, which we don't normally use ourselves, to get an iterator from it. And once you have an iterator, you can pass it to the built-in next function to get just its next item. But if you pass an iterator to the built-in next function and it's exhausted, meaning it has no more items left in it, you'll get a stop iteration exception. Now, iterators power all forms of iteration in Python. They power for loops, they power comprehensions, they power tuple unpacking, they even power the star operator used to unpack items into separate arguments in a function call. Anything that involves looping involves iterators under the hood, which means we could actually re-implement a for loop ourselves without a for loop by calling iter to get an iterator, repeatedly calling next on the iterator, breaking out of the loop if we get a stop iteration exception. That's actually how for loops work under the hood in Python. Otherwise, executing the body of our loop. This function works because this is what for loops actually do under the hood in Python. Now, generators can be passed to the built-in next function, which means they're iterators. But we normally loop over generators, which means they're also iterables. So generators are both iterators and iterables. This is actually true of all iterators in Python. This is where things get a little bit weird, if they weren't weird enough already. So every iterator is also an iterable, and any iterable in Python can be passed to the built-in iter function. That means that an iterator, like this generator object, can be passed to the built-in iter function. What do you think we'll get if we pass an iterator to the iter function? So the built-in iter function gives you back an iterator when you pass an iterable to it. And since iterators are also iterables, but they're iterators, they give you themselves back. So when you pass an iterator to the built-in iter function, it will give you itself back, which is a little bit weird. Now, this is all called the Iterator Protocol. These are the rules that make all forms of looping work in Python. An iterable is an object that can be passed to the built-in iter function to get an iterator from it. Once you have an iterator, you could pass it to the built-in next function to get its next item. And when an iterator is exhausted, if you pass it to the built-in next function, a stop iteration exception will be raised. But also, crucially, iterators are actually iterables themselves, which means you can loop over them. They return themselves back when they're passed to the built-in iter function. So an iterable is anything that you can iterate over. An iterator is the object that actually performs the iteration over an iterable, but iterators are also iterables themselves. They're lazy iterables. They get consumed as you loop over them. So normally if you have a generator object, which is an iterator, you wouldn't call next on it repeatedly. You'd probably loop over it. Just as sequences are the generic form of a list-like object in Python, iterators are the generic form of a generator-like object.